Chris, development team doing some neat stuff.
Cool. Well, thank you, everybody. Great to be here with you. I know it's a shame that so many people were not here, but at least we're here, and I'm thankful for that. My name is Bruce Momjian. I live in the United States. I am one of the Postgres core team members, and I work for Enterprise DB. As part of my work for the database, about 9 months ago, I decided to do some research to understand cryptography from the mathematics all the way up to the implementation. And you're looking at one of 4 presentations that came out of that research. The slides that you're looking at today are actually at this website right here. If you just put my name as crudely as you can in the search bar, it will find my website. There are 4 security presentations under the presentations tab, and there are also 20 or 30 other presentations related to Postgres, including recordings of those presentations. So again, I hope you enjoyed it. We have about a half an hour, and I am excited to be giving this for the first time, brand new presentation, and very exciting. So what are we going to talk about today? Looks like a lot of information for 30 minutes, but we're going to do our best. I do have some presentations on my website that talk about cryptographic fundamentals, cryptographic communication, cryptographic hardware installation and configuration. And this is the final talk, which basically talks about applying cryptographic hardware to actual problem domains that you have. The previous presentations, again, cover things like TLS, AES, public key cryptography, RSA, Diffie-Hellman, elliptic curve, and also the complexities of configuring things like a YubiKey. If you're familiar with that device, I actually happen to have one with me, which you probably won't see because it's so small that you will probably have trouble. But it effectively is stuck in my USB thing here. Yes, it is this huge device. Oh, and I have unplugged my thing, and I will replug it in as soon as the blue light comes on. There we go. There we go. It should come back. Yes, there we go. Oh. There we go. Thank you. So this is actually a YubiKey right there. That little, if I can hold it, yes, that is it. It fills the slot is about all you can say about it. But effectively, it is a way of cryptographically storing secret keys that can only be accessed through the hardware. So unfortunately, I don't have time to talk about that because 30 minutes is not going to allow me to do that. But the point is, and again, feel free to look at my website to get the details. But the point is that normally when you're doing something cryptographic, you have to store the secret on the same computer that you're using, right? And obviously, if anyone gets access to that computer, they can copy that key off and do all sorts of things with it. The creative thing about the YubiKey and all of the hardware-specific devices is that the key is only inside the device. It never leaves it. It can't be copied out of the device. I think that's the key point. So that unless somebody steals the physical key, there's no way of copying it in a way that's undetectable. Okay, and I think that's the real win. But what I'd like to talk about today is effectively how, hold on. Oh, interesting. Okay, and we're just going to leave that up there. Okay, is specifically how to use hardware cryptography for specific applications. We're going to talk about OpenSSH. Then we're going to talk about GPG or PGP, depending on how you want to say it. And then we'll talk about Postgres as a conclusion. Okay. So again, as I said, the YubiKey, which we're not going to cover unfortunately today, is actually a hardware device that sits in your USB socket, and there's a whole bunch of configuration that you can use to basically set up that YubiKey. For those of you who aren't aware, OpenSSH is effectively a remote shell command. It allows you to SSH or create a shell from one machine to another machine. The reason it's different than a normal shell is that it is secure, because TLS is used, and therefore it's impossible for somebody to see the communication as it's going back and forth. Normally, when you're using SSH, you have to have a private key stored in the file system of your device. Okay, so the key is actually, you can do an LS, you can see the key. It says something.key if you've ever seen that. One great thing about using hardware cryptography is that effectively you can have the system not get the key from the file system, which is obviously susceptible to things like backups and people copying it and so forth, but you can actually get the key off of the USB hardware device, in this case the YubiKey, and therefore it's not possible for somebody to steal it without being detected. And of course it will not show up on a backup and so forth. So what I'm doing up here is I'm effectively trying to connect to my machine, and I'm getting a permission denied. So what I can do with the YubiKey, and again, all the configuration, unfortunately, is in the previous presentation that we never can get to, is that I'm using a utility called PKCS15, which is actually a tool that you would run on Linux. This happens to be an Ubuntu machine. And it's basically saying, I want to run that tool to access my cryptographic hardware. I want to read key number 1, and I want to output the public key that's stored in the YubiKey, the little device. So I can't take the private key off of here, but I can take the public key off of here. If those of you are familiar with public key cryptography, the public key literally is public. It's nothing secret about it. It's the private key that's the one you don't want other people to see. In fact, you can't see the private key. Once I put a private key into a YubiKey, I can't even see the private key. So I'm saying, give me the public key from the YubiKey, and it actually looks like this, although there's a lot of dots here, so it actually would go really long, but I want to get on one slide. Okay, so that's what it looks like. So effectively what I do is I take that public key and I copy it into the SSH authorized keys file. Okay, and then I remove the public key because I don't need it anymore. And then when I want to use SSH to connect, I effectively have to tell it how to connect, where to get the key from, the private key, and I now connect to that as that user, and I actually get a prompt, not for the password, not for the private key password, no type of type that out, but effectively anytime I go to access the YubiKey, a second security measure is that I have to type a password of some type, typically 5 digits or 4 digits or 6 digits, to be able to access this device, okay, access the little YubiKey. And in fact, once I do that and I type in the thing, I actually get an ID, a prompt, and if I ask who I am, I've now SSH'd in as Postgres when I wasn't using Postgres up here because I was somebody else. Okay, so my point is from this slide that you're basically going in and you're configuring, putting the public key out and registering it with that user, then you're using it to log in. Okay. PKCS11 is actually the protocol that we're using here. Here's a little more sophisticated example where I'm actually configuring SSH. I actually have a little script here that I've got a host name and a provider, and I'm actually setting that up in the SSH config file. And now if I do that, I don't need to prompt for this OpenSC anymore. I've now registered OpenSC in SSH config, and therefore I can just type SSH, the name of the person I want to become or the host I want to go to. I get prompted for the PIN, and boom, I am actually there. And of course, there is a URL there if you're interested. Okay. Actually, hold on. Let me just fix that because that's annoying me now. Let me try to get rid of that little thing there at the top there. Oh, it went away. Okay. Figure that one out. Okay, great. So that's another one. There is something called SSH agent. I'm not sure how many of you are familiar with that, but it allows you to avoid continually typing the PIN in for the YubiKey. So it basically loads the key into memory, not on disk, loads the key into memory, and then you don't have to keep typing the key. This is how you configure it. Again, I expect if you want to use that, you would probably download these slides and try it. And again, I run SS agent, and I type the pin once, and then now I can SSH, and I'm not even getting prompted anymore for the pin. Okay? Or I could use this protocol here. Either one would work. And again, we have some URLs to kind of help you along. Okay? This is actually a script. I don't expect you to read it, but it's actually a script that I wrote that allows me to run the SSH daemon in the background. Effectively at boot, I can run this, and if SSH agent hasn't been configured, it configures it, and then it keeps it running, so therefore I don't have to kind of keep typing it in all the time. So this is just a script. If you're interested, feel free to cut and paste it and edit it. But effectively what it's doing is it's adding the key, and then it's adding the agent, PID, and it's making sure that your SSH agent is running. And again, this is sort of another URL for you. Okay? And again, this is how you would install it, SSH agent D. Run it as, in this case, I made root own it, and I just put it into user bin. Okay? L bin. Okay. Again, if you're using SSH agent D, you would run it like this, and now when you kind of log in, it actually tells you some information about it, and it works really well. Here's some examples. Again, SSH into somebody, and you're becoming that. Okay. I would love to take questions, but I have a feeling I don't have time. So if we have time at the end, I'll definitely be doing that. Number 2, OpenPGP. You're probably familiar with that. It's sort of the command line tool that most people use for cryptographically signing things like emails and documents. This can also use the YubiKey in some really interesting ways. Again, originally designed for email, but also now used for signing and encryption. Does file encryption, signing, Git signing, even Postgres stuff actually uses this. Okay. Sorry. Again, a little history of OpenPGP and where it came from. GPG, if you're familiar with that name. Expiration of certificates and things. There's a lot of details here, but I'm going to have to kind of zoom through it. But effectively, this is how you install it. You're installing GNU PG, which is GPG, long name, and you also have to install something called SC daemon, which is basically the smart card daemon for Linux, which allows OpenPGP or GNU PG2 to access cryptographic hardware. That's what the SC stands for, secure. Smart card daemon. Once you do that, you can actually run GPG2 and ask for the card status. And effectively, there it is. It's actually showing us the literal YubiKey information that it's pulling out of the little card that I keep seeming to reach for in my thing, but it's so small that you probably can't see it still. But in fact, it tells me it's a YubiKey. It tells me the version. It tells me that some login data about the person, different key attributes, and it even talks to me about the signature key, the encryption key, or the authentication key. There's actually, YubiKey has several slots inside of it. It's not just one key. You can put a whole bunch of keys in there. And in fact, it's saying right now that those are empty. So this is telling me that my card, my YubiKey right now doesn't really have anything installed. Again, feel free to look at that URL if you wish. There is a GPG agent D that I wrote, again, to make use of this thing really easy. Feel free to copy it. But here's an example of how you would use it. You'd start GPG agent, and then you can actually type GPG connect agent, and you can actually reset the card. I know this is kind of gobbledygook, but this is how you do it on a YubiKey to reset the card. Then you have to configure the pin for the YubiKey. Effectively here, I'm generating a random number, okay, that's 6 digits. I'm just shooting 6 digits out here, cutting the first 6, making that my pin, and then effectively I go in and I set my pin into that file, and now I can basically run and I can change my pin, and I set my pin to be that number. This is another password you have to use for the administration password. That's one's 8 digits. So effectively, once you've reset the card, this is what the card looks like right here, blank. Okay? Again, I told you there's a whole bunch of slots you can create in the YubiKey, but right now they're all blank. And of course, GNU PG also doesn't have anything in it. So the first thing we have to do is we create a master primary key in GNU PG, and then we create a signing key, an encryption key, and an authentication key, all in here. And then we have to populate the keys in here to match these. So effectively what we do is we generate all the keys on the operating system, and then we effectively slice off the private key, the secret key, the private key, and we copy them over into the YubiKey. Okay, remember I said that one of the beauties of the cryptographic hardware is that effectively your private key is not stored in the file system. Okay, so the way you do cryptographic hardware with GPG is you effectively generate the keys on the file system, and then you copy those files, the private part, into the YubiKey where no one can see them. And then you erase that part. Okay? Here's an example. GNU PG2, I say generate a key. And this is there's going to be a lot of screens here, but just bear with me. I basically am going to say, okay, what kind of key do you want? And then how long do you want it to be? And then when do you want it to expire? And then what's your name and what's your email address? And you want to go and you say, okay. And then you basically go and you edit the key, and you can actually see this. I now have a public key in my in Open PGP. Okay, again, a URL here for help. Then I can add another key, go in and add a passphrase. I want an RSA key in this case. I want now an encryption key to be added that's signed, and we're going to quit there. Okay, no expiration in this case. So effectively, this is a cheat sheet of how to understand the GPG2 labels. A is authenticate, C is certificate of creation, E is encrypt, and S is sign. Remember I said there's 4 different keys that GPG typically uses. These are the labels you'll see. So now I'm looking at my key. I have one public key, and in this case, 2 public subkeys right here. And if I toggle to look at the private part, I have 1 secret key, and I have 2 secret subkeys. Okay. I do apologize. It is a lot of material to go in. I mean, we're on slide 33 of 94. Okay. So I'm doing my best here, folks, but you got to take the cards you're dealt. Again, if we look at the card at GPG itself, we have 3 keys. We add to the card key, and now this is going to copy all of my private keys over into these systems. So I'm now going to copy the encryption key over. In this case, now I have 3. Now I've copied it over. But you notice that this one actually says it's in the card. See how all of these are public and they just look like one line, right? 2 of these are public, are private, and they're still on disk. And this one actually has already been transferred to the card. Okay? I'm going to do the same thing again. See, again, we have 1 transferred to the card. I'm going to basically say copy all the private ones over. And now if I look at my private key, all of these are now in the card itself. Then I'm going to delete the secret keys, because remember I've transferred them to the YubiKey, so I'm going to get rid of them now. I'm going to just get rid of the private keys on disk so that they're only on the YubiKey, and then pull them in. I know, again, more information there. So if I now look at my setup here, I've got the 3 public keys. We're going to now remove the encrypted subkeys to the card, kind of run through key to card, and now I'm going to shove that over. See, signature key has nothing, encryption key has nothing, authentication key, now the card's telling me it has 1. Okay? Again, encrypt the key. Now I've got 2 of them over here, card number right here. Okay? And now I'm going to do this one, and I'm going to do key to card again, and now I got 3 of them. Bing, bing, bing. All 3 of them now are on the YubiKey. Okay? And I'm going to save. Right? So now when I look at my YubiKey, we're back to the YubiKey. Okay, we're not looking on disk. We're looking at the YubiKey. Now I have a signature. Remember this was empty before? Do you remember the previous screen? These were all said none. Now in the YubiKey, I've got a signature key, encryption key, authentication key, and the dates. Okay. So if I now look at my YubiKey, you can see they're all kind of marked. They all have card numbers on it. This is an important indicator. It says that there's a pointer here, that inside GPG we don't have the key. We have a pointer to the card slot, and that's what that's telling me. Okay, and that's pretty typical. So now that we've sort of set everything up, let's actually use that key to actually do something. So what I'm going to do is I'm going to take the word test, and I'm going to encrypt it with GPG2 with some armor. I'm going to send it to, I'm going to use that as my key ID, and then I'm going to decrypt it. So I'm going to take the key, I'm going to take a word, I'm going to encrypt it with that key, and then right away I'm going to decrypt it. So the test goes in, and bingo, test comes out, right? And the interesting part is that we've actually used the YubiKey to decrypt this. The public key was always on disk because we don't care about the public key. Anyone can see it. So we don't have to transfer the public key over, but the private key certainly use the YubiKey. Here's another example. If I do test and I do a check, I sign it with GPG2, I can actually say signatures made, and it's talking about when I signed it. So that's a signing of that message, just a little different usage here. Okay, you can actually use the OpenGPG and OpenSSH together. So remember I showed you before how to configure OpenSSH with a YubiKey. Well, you don't have to use the YubiKey directly. You can use OpenSSH. OpenSSH can use GPG, which uses the YubiKey. So you're now putting a new layer in the setup here. So here's an example. Let's pretend I can't log in. Now I can actually use, I can take my SSH out, I can throw it into a file, and now I can cat it over to 7 minutes. Yes. Okay. I can cat it into authorized keys, and now I've become that person. This is a kind of software stack for cryptographic hardware. Here's the YubiKey over here in green. Okay, we have 4 slots, 1, 2, 3, 4. Certificates here, public key, private keys over here, and then there's an open GPG section inside the YubiKey, and also auth slots. And again, all the software that's used to access that is there. Okay. So just a little comparison, if you've ever heard of PIV. PIV is the government standard for encryption. This is just a slide that talks about some of the advantages of when you would use OpenSSH, when you use GPG, when you use PIV. Again, I'm not going to go into this because we don't have time. Let's finish off by talking about Postgres, which I actually know quite a bit about. We basically normally have a challenge in Postgres of how to store private information, how to store information without anyone seeing it. One of the tricks to do that is to place a private key on the client side, and just as I use GPG to encrypt and decrypt, I can do all my encryption and decryption here. I can also do some decryption and encryption over on the Postgres side. Another idea is to to encrypt it on this side and then just decrypt it on that side, have some kind of symmetric key. That's pretty simple. Here's an example where we actually create a table for each user, and each user gets a symmetric encryption key. Okay? And effectively what we do here is we, at the client side, we use OpenSSH and we create a symmetric key. Then we echo the symmetric key and store it into a variable. So here's my symmetric key, here's my encrypted symmetric key, and then we create a signed hash of that. Again, a whole lot of OpenSSH going on in here, sort of to encrypt that. Well, what's interesting is that when you send a query to Postgres, we can have the client send its encryption key over to Postgres. Postgres can encrypt it and then store the encrypted data on the Postgres side. The problem here, of course, is you're sending this encryption over the network, and Postgres is seeing that symmetric key, which is kind of yucky. You can actually retrieve your own symmetric key by doing a select, and then you can decrypt the data on the client side doing the same thing. Similar here, you can get the symmetric key. This is actually what the symmetric key looks like in my particular example. However, that's kind of interesting, but notice if I take the YubiKey out of the server, or so I take the YubiKey out of the server, all of a sudden I can't actually do my encryption anymore, because effectively it can't get to the key, the private key anymore, to figure out how to decrypt that. So it's kind of a multi-layered approach. You basically create a symmetric key, and then you encrypt it with the YubiKey. That's usually the way most encryption happens. You don't actually use public key encryption or public key encryption for data encryption. You normally use public key encryption to encrypt a symmetric key. That's the way TLS works. That's pretty much the way most of them work. So effectively what this solution is doing is doing that. Here's another example, a little more complicated, where you're creating a secret message, and you're encrypting it with the YubiKey in this case, and then you're basically sending it into Postgres, and it looks like that. Now you can retrieve it and encrypt it. Again, it's pretty complicated. I'm not sure how many people are actually interested in this level of detail for Postgres, so I'm trying to go fast. But again, Postgres has cryptographic support in at the server. It also has the ability to store cryptographic keys in Postgres as well. This is a little more sophisticated case where we actually use the server, and we store the secret key in the file system, but we encrypt the secret key in the file system with the YubiKey. So we're storing the key on the file system, but the key isn't stored decrypted. The secret key gets another level of encryption using the YubiKey. So every time Postgres starts, it decrypts that particular key and then uses it to encrypt and decrypt data. Again, very sophisticated. This is some examples of that. Here's an example of the actual key being used. Here's an example of exactly how you would kind of access it. You can get even more sophisticated. You get a per user keys. Again, this is very complicated. This is actually a server-side function that's written in the Perl language, which allows you to kind of do that. So I'm just going to kind of zoom through here. The point is that you have actually transparent encryption in Postgres by using this. And again, this is way more than you want to hear. But keep in mind that there are performance issues here too. Again, I'm going to try and take one question or two. But feel free to look at this. This talks about database encryption. Probably not something people are interested in so much. Let's see. So, okay, so let's take one question, two questions. I think I have 2 minutes to take some questions from people.
Is it possible to make a backup of the private key when it comes in?
So the question is it possible to make a backup of the private key? What we normally, before you put on the YubiKey, what we normally tell people to do, and you're absolutely right, is when you create the key you're almost always creating, you can create the private key on the YubiKey, okay? But if you create the private key on the YubiKey, you can't make a backup of it because you'll never see it. So what we normally tell people to do is create the key in OpenSSH. So create the key in the file system on Linux, make a copy of that key to a USB stick that you can take away, then copy it to the YubiKey and delete it. So you probably want to generate the keys on your Linux machine, make a copy of it that you can take offline, copy that also to the YubiKey, and then delete it from your file system. That's normally the way to do it. The normal way, actually, I would tell people to do it is to literally put a USB stick in, create the YubiKey on the USB stick, not in your file system, right? Not in your Linux file system, but create the key on the USB file system, right? Copy that to the YubiKey, and then pull the USB stick out. So the key is never hits your platters. Another question. Yes, sir.
Why did you focus on UBT and, for example, on TPM?
I'm sorry?
Why did you focus on the UBT in particular, and why you didn't use like TPM that is embedded in all modern laptops?
So why did I use YubiKey instead of TBM? I found a lot of open source support for the YubiKey and the ability to extract it from the device. Because if you take the key out, that machine has no, So honestly, I haven't. It never came up in my research. I never actually saw it as an option for Linux when I was doing research. It's possible. I'll take a look. One more question, maybe.
I think
We're good. Okay.
thank you.
Thank you very much.